This is Algebra 2, Lesson 23 on page 108. All right, so the title of this lesson is Graphical Solutions. And the instructions for each of these types of problems say to solve the system by graphing it, then to check the solution by using substitution or elimination. Okay, I never want you to solve a system of equations by graphing. Because what if the intersection is here? Do I want you guessing what is between 1 and 2? Do I want you, like, that's 1.5, that's 1.25? No, I don't. But the whole point of this lesson is when we solve for this coordinate point through substitution and elimination, and we get a coordinate pair of, say, 3/2 and maybe 6/5, something like that, that this coordinate pair represents that point where those lines are concurrent. But I have taught you that from the very beginning. When we're solving for the X and the Y coordinate point using substitution or elimination, we are always solving for that point where those two lines intersect each other. All right, so do you acknowledge that that's what we've been solving for? Do you understand that that's what we've been solving for? So never look at a graph and guess what the solutions are. Use substitution or elimination. Okay? All right, so let's work the examples. 23.1. We're not going to graph them. We're going to use substitution or elimination. And I will let you decide. All right, so here is the system of equations. This, maybe I've never said that word. This is called a system of equations. Maybe I just said that word for the first time. And we're solving for that point of concurrency. All right. So what do you want to use? Substitution or elimination? Substitution. I prefer elimination. It doesn't matter. Let's use elimination. Okay, so, you know, when I first started teaching, I preferred substitution, but the more I teach, the longer I teach, and the higher level I teach, I prefer elimination. So what are we going to eliminate, X or Y?
X. Is it already?
Yes, X, because X is second. And, yeah, I was almost going to say Y because I knew it was the second term, and typically Y is the second term. All right, so we're going to multiply every term by 2. So we end up with 2y plus 2x equals -2. I'll write the other equation under it. Our x's eliminate. We end up with 5y equals 4. Y is 4/5. And then we'll go and substitute it back into the easier of the first two equations. I'm going to substitute in the first one. So 4/5 plus the value of x gives me -1. -1 is the same thing as 5/5, right? So that's -5/5. I subtract 4/5 from both sides, and the value of x is -9/5. That point of concurrency is -9/5, comma, -4/5. I mean, would we really be able to guess that point if we graphed it?
It's negative.
It's just 4/5, positive 4/5. Thank you. Positive 4/5. All right, look at example 23.2. our first equation is y minus 2x equals 2, y equals negative 3. Substitution or elimination? Now is when you'd obviously use substitution. So for y, I will substitute negative 3 minus 2x equals 2. Add the 3 on both sides. To eliminate that 3 on the left, I'm left with negative 2x equals 5. When you divide both sides by negative 2, x is negative 5 halves. We already have y. That is the place where those lines intersect one another.